Hello viewers, welcome, and in this tutorial I am going to show you how to make a large model and train this model. So as a sample I have taken VGG16, which is a quite large model, and if I show you the paper of VGG16, and VGG stand for Visual Geometry Group. It is a group team from University of Oxford, and they took participated in a competition of ImageNet in 2014, and they stood fast out there. And this is the skeleton of VGG16 out there, and they have taken images of shape 224 by 224 and 3-channel image, RGB image out there. So the input is 224 by 224 by 3, and then they pass that to conv and then to a max pool, and again to conv then max pool, and again for conv then max pool, and for conv then max pool, and again for conv then max pool. And then they have used fully connected layers, that is dense layers of 4096, and again similar type of fully connected layer. And to the final, for 1000 classes of images, they have used 1000 neurons out there. So this is the main skeletal elements of VGG16, if I say. And if I say about the data sets, they have taken 1000 classes of images, and for training set they have created 1.3 million images, and validation data was consist of 50k images, and testing set was consist of 100k images. So it's quite a large data set out there. So the main conclusion of this model is that to have a better prediction of images, you need to go for deeper and deeper neural networks. So this is all for the paper of VGG16. And if I show you the image of VGG16, so this is VGG16 architecture. So they have taken 224 by 224 by 3 channel image, and then some conv, then max pool, and they have used zero padding out there. So the shape remains same, but and channel increased out there, so channel is 64. And now for the max pooling they didn't use padding out there, so the shape has changed from 224 to 112. And here they have used 128 filters, and again here in this layer 256 filters, 512 filters, and gradually they have used 496 fully connected layer. And to the final, for 1000 classes of images they have used 1000 neurons, and they have passed through a activation function of softmax. So this is all about the architecture of VGG16, and the main purpose of this tutorial is to learn how we can make a large model and how we can train them. So let's dive in and see how we can make a large model and VGG16. And in the second part of this tutorial I will be showing you how to train this model. So let's make the model now. So import Tensorflow STF. This is what I'll be needed. Then input layer, make an input layer. So input layer equal to tf dot chars dot layers dot input, and get the input of 224 by 3. So this is the shape of the image, each of the image which I am giving, and then I'll be passing this layer to 2 conv layer. So write out there conv1 equal to write out there conv1 equal to, so tf dot chars dot layers dot write out there conv2d 2D and pass out there the filters number. So filters I am going to use here 64 filters. Now kernel, and I am going to use the number of kernels out there. So kernel size, you can say this one, this is as window size. So they have used all the conv of window is 3 by 3 shape. So 3 by 3 shape, and strides out there. So strides equal to again 1 by 1. So this is the things. And another thing you can do is give a name to this layer. So name equal to, I am giving as conv1. Now conv, I'll be passing this. Okay, all I have to do, so I have created a callable class out there, object out there. So I have to pass out there input layer. So this is what I have done. Okay, now I am going to create the second conv layer. So again tf dot keras dot layers dot conv 2D and pass out there filters, again 64 filters out there, and give the kernel size equal to 3 by 3. And another thing I forgot to do is I have to give out their padding. So just bring this here and write out there padding equal to, I want to keep it same. Okay, so I have done padding, and then I can give a activation function out there. So they have used activation function of rectify linear unit. So I will be using that. So just use that activation equal to rectify linear unit. So yeah, so my input layer is passed through a conv layer, and I have given a name out there of conv1. So let's increment this one conv11, since okay, give this variable as same name so that I do not contradict. Okay, and here I will be using strides, and again strides of 1 1. Then padding, so padding I will be keeping the same, and activation I will be using the same rectify linear unit. And then name out there I will be giving conv1, and that is 2, and I am going to pass this conv11 to this here. So conv11 here. Okay, fine. So I have done, if I show you the image, so I passed this input layer and done to convolution out there. Okay, now I will perform the max pooling out there, and for max pooling I have to I do not have to give padding out there. So I will be using pool 1. So pool 1 of 1. So I'll be using tf dot, right out there tf dot nn dot max pool. So this is a function, this is not an object. So I have to give this conv, so conv1 to out there. So pass conv1 to, and say that kernel size k size will be give out there 1 2 2 1. So here it means that for number of batch size I do not want to divide, so it is keeping as 1. And here for each of the images slice I am giving a 2 by 2 window, and here for each of the channels I am dividing by 1, so I will go individually through each of the layers. So this is what I have to do. And yeah, kernel size is given, and let's give the strides out there. So strides equal to, let's give it 1 2 2 1. Okay, and I have to give out there the padding, so let's give the padding. So here for this function, same means is a different concept, so let's see the function out there. So this is tf.nn.maxpool, and if I see the documentation, and here padding equal to valid or same. So if I go further, then let's see what valid means and what same means. So for if I apply same, then it will perform this thing out there. So for padding equal same, output spatial shape equal to cell input spatial shape divided by strides. So there the strides I have used out there is 2. So if I say the shape is 224, then stride is 2, so 224 divided by 2, so it will come half, that is 112. So this is what I am in required of. So you can see the height and width out there is 112, and the channels out there is 128. So when I will go to the conv layer, then I will give 128 filters for 128 channels. Okay, I think that's done. Then I have to give conv2 of 1, then tf dot keras dot layers dot conv2d, and pass out their filters. So filters equal to I'll be using 128, right? Yeah, let me see. Yeah, 128. So again, now I have to give kernel size or window size of 3 by 3, and strides out there, so strides is 1 of 1. Okay, now padding out there, so padding equal to same. So for Tensorflow keras.layers.conv2d, same means it will have 0 padding surrounding the image or feature, as you see. So I will be using activation out there, so activation equal to rectifier linear unit, and give a name out there, so conv21 out there. Okay, now I have to, since it's a callable object, I can pass out there pull 1 out there. So done. Now again conv22 equal to tf dot keras dot layers, pass out there conv2d, give the filters out there 128, and give the kernel shape or size out there. So kernel is 3 by 3, and give the strides out there, so strides is of 1,1, and padding out there I will be keeping same, and activation rectifier linear unit, and then name, give a name of the layer, so it is conv22, and pass out there conv21. Boom. So now I have to, so I'm done with these two conv and max pool, and then these two conv. Now I am going to perform max pooling out there, so let's do so. So pool 21, name it as 21 and give out there I can give a name out there. So name equal to pool 11. Okay, tf dot pooling is under nn, so max pool. So if you do not like TensorFlow nn.max pool, you can use tf.keras.layers.max pool 2d. So then you can give the kernel size, that is case size is 2 by 2 and its strides 2 by 2, so it will perform the same thing. Okay, so max pool out there, and I will be going to passing 2 out there, and case size equal to give 1 comma 2 comma 1 and give out the strides. So strides equal to 1 comma 2 comma 2 comma 1, and pairing I'll be giving same, so that it make the feature to half, and give a name out there. So pool 21. Okay, fine. Now I'll perform convolution. So conv31 equal to tf.keras.layers.conv2d, pass out there pool 21. Oh sorry, I'll be giving number of filters out there. Filters, let me see the number of filters out there. So they will be using 256 filters. So use 256 filters, 256, and give the kernel size out there. So kernel size equal to 3 by 3, and give out there strides. So strides equal to, I'll be using 1 comma 1, and give out their padding. So padding equal to same, and activation equal to rectified linear unit, and then name equal to conv31, right? Yeah, conv31, and pass out there pool 21. Now conv32 equal to tf.keras dot layers dot con2d, and pass out their filters equal to 256, and give the kernel size out there is same of 3 comma 3, and give the strides out there, strides equal to 1 comma 1, and padding I'll be keeping same out there, same, and give activation function, activation equal to rectified linear unit, and then name. So give a name out there, name conv 32 out there, and pass out there conv31. Now I am done conv33. So there are 4 conv layer, tf.keras.layers.conv2d, and pass out their filters, and give out there 256, and kernel size out there is of 3 by 3, and strides out there equal to 1 comma 1. Oh sorry, okay, and give out the padding. I'll be keeping the same, and activation out there. So activation equal to rectified linear unit, and then name. So give a name out there, conv3. So this is the name of the layer. So one of the good thing of giving name is that you can call this layer by its name. so conv 32, and I'll be making 4 layers, I think. 1 2 3 4. Yeah, I have to make another one. So just copy this line, Ctrl C, and bring it here. So 256 333, and change these to 4, and change these to 4, and pass out there 3 3. Okay, so now, so I made out there 4 conv layer. Okay, fine. Now I have to give a max pool. So pool 3 1 equal to tf dot nn dot max pool, and pass out there conv 3 4, and give out their case size. So kernel size equal to 1 comma 2 comma 1, and give out the strides. So strides equal to 1 comma 2 comma 2 comma 1, and padding out there. So padding will be same, so write in capital letter. Okay, and give a name out there. So name equal to pool 3 1. Okay, fine. So let's comment some here. I can give out there as block count block 1. Okay, so up to here it is block 1, and here it is block 2, and here it is block 3. Okay, I have to give it mistake over there. Now, okay, fine. So I have done with 3 blocks. So let me show you 1 2 3. So these 3 blocks are done. Now I have to perform these 2 blocks and then fully connected layers. So let's do so. And block 4 equal to, then pass over there conv 4 1 equal to tf dot, again I can just copy paste here. So copy paste this and write out there 4 1, and give out there number of filters I have to know. So here 226 and now 512, so I'll be required 512 filters. So 512 filters, done, and keep the name out there for 1, and pass out there pool 3 1, pool 3 1. Okay, fine. Just copy this line, Ctrl C and Ctrl V again. Now just rewrite something, and this is 4, and write out there 4 2, and pass out there conv 3 1. So conv 4 1, sorry, 4 1, fine. Then again, and pass out there conv 4 2, so 4 2, and give the name out there of 4 3. So this is 3, and change the name here 4 3. Okay, fine. Just copy this line, Ctrl C, Ctrl V, and here I am going to pass 3, and filter size is okay, and change the name out there is 4 4, and here change the name 4. So block done, block 4 done. Now perform the polling out there. So poll obviously for 1 and pass out their tf.nn dot max pool and give out their con 44 and write out their k size. So k size equal to, give out their 1 comma 2 comma 2 comma 1 and give out their strides. So strides equal to 1 comma 2 comma 1 and I have to give the padding out there. So give a padding equal to same. Fine. Done. So block 4 is done. Now block 5, just comment this here so that you can understand. Just Control B. So here write out there 5 1 and let me see the number of filters out there. So they have used same number of filters, 512. So 512 write out so it's 512. Okay, fine, and write out there 5 1 and pass out there pool for 1 out there. Okay, fine. So again perform Control B. So it will be 5 2 change the name here 5 2 and pass out there con 5 1. Fine. Yeah, again I have to pass out there 5 2. Fine. Change the name here 5 3. Here change the name to 5 3. Fine. Okay, I am almost done. Control B. So change the name here, pass out there 5 3. So 5 3 and change the name here to 5 4 and give out there 5 4. So now fifth block is done. Now I'll be performing max pooling out there. So let me see the skeleton. 1 2 3 4. Okay, they have performed 4. Okay, so it's done. Write out their pool 5 1 equal to tf.nn dot max pool. Give out their con 5 4. So con 5 4 and write out their k size. So kernel size equal to, give out their 1 comma 2 comma 2 comma 1 and give out the strides. So strides equal to 1 comma 2 comma 2 comma 1 and padding out there, padding I'll be keeping the same. So PSAME and give a name out there. So name equal to pool 5 1. So write out there pool 4 1. Okay, so that was the name out there. I forgot to give a name, make it a string. Fine, everything looks cool. Okay, fine. Now I have to perform the fully connected layers. So flatten. So before performing fully connected layers, I have to flatten the feature. So flatten equal to tf dot keras dot layers dot flatten, and pass out there the pool 5. So pool 5 will be passed. Now I'll be performing fully connected layer. So let's give it fc6 as name. You can give any other name. tf dot keras dot layers dot dense. So give out their units, so number of neurons. So they have used, so let me see the paper, and you can see they have used 4096 neurons. So there is large number of neurons, and the data set which I am going to use to train this model, there are 5 classes. So I will be not needed that much of neurons. So I'll modify this shape over there. So let's give 256 out there. Use bias, so it's by default is true, and give a name out there. So name equal to fc6, and give the activation. So activation I'll be using rectified unit and pass out there. So since it's callable, so you can pass out there flatten. So let's pass flatten, it's fine. Then I have to give fc7 fully connected tf dot keras dot layers dot dense, and give out their units equal to I am going to use so 128. So 128 neurons, and give out their name. So name fc7, and give out their activation. So activation equal to rectified linear unit, and pass out their fc6. So 2 fully connected layers is done, and I have to go for the last fully connected layers. So I have a data which is flower classification data, and there are 5 types of flower. So I am going to use 5 neurons. So fc8 equal to tf dot keras dot layers dot dense dot units, give the units out there. So units of 5, and a name out there fc8, so that you can call this. And I'm not going to use activation here. So activation equal to, okay, you can use activation. Activation I'll be keeping blank. So activation equal to, by default it is none. Okay, I am rewriting it. So fc7 out there, pass out there. Now probe equal to tf dot keras dot activation, sorry, tf dot nn dot softmax. So pass out their softmax, and pass out their fc8. So I'm done with my model. So this is the output of my model, and this is the input layer. Okay, so now I'm going to create the model. So model equal to tf dot keras dot model, and input layer, and give out there the probe, which is the output. So my model is done, and now I want to save the whole model. So just use model dot save, and my model, give out there my VGG16 .h5, or you can give any other name. So I am giving this name. So this is the whole model. Now This is only the layers which I have defined. Now I have to define the loss function, the optimization functions later when I am going to train. So this is all for this tutorial, and I am done with my model. Let's run this code. Let's see if I get any error. Hopefully I will not get any error. Okay, it's saving, so let's wait. Well, I didn't get any error. That's great. So this is all for this tutorial, and if you like my effort, please subscribe, and as always, thanks for watching.